All right, this is for Algebra 1. This is 5C, and I did not mention this in class, but we have Rene Descartes to thank. He is the one that developed this graph to show algebra geometrically. So let me focus in on this is Rene Descartes. So that is who we have to thank for this lovely graphing that we're getting ready to start. All right, so there you go. Now, some of you have called me and asking me how to plot or how to graph these inequalities. These are called inequalities right here, greater than. This one happens to say less than or equal to. If there's that little line under there, you say or equal to. Okay, so how do you do this? So let me sketch this out real quick. And let me grab a pen. Let's see here. Sorry, thought I had this ready. Okay. This point is not exactly on your number line in your book, so you're going to have to approximate. This is -2 3/4. So -2 3/4, I just am lazy and only put about every other point, and I hope that's clear enough. It's kind of dark in here because it's about 6 in the morning. But -2 3/4, it's going to be about right here. So I'm going to have to peek around my phone right there, but it's going to be about right here. So I'm just going to put a little slash there, and I'm going to label it -2 3/4. All right, so it's going to look something like that. Now, I look at this. This you have to decide, are you going to have an open point or are you going to have a closed point? Because it's just strictly greater than. It doesn't have the or equal to under it. I'm going to have an open point. Okay, that's true if it would have said greater than or less than. You have to decide very first what kind of point you're going to have, and it doesn't include -2 3/4. It just includes everything bigger than that. So at this value where you made it, you're going to put an open point. Okay, and it wants everything greater than that. Well, that would be all of this. So you're just going to shade in on your graphs in your books. Just kind of draw a real nice heavy line so that it shows up. And then you're going to arrow in, shade in the arrow so that I see that it's going on forever. Okay, so how does that compare to this one? Okay, again, 1.7, it's not a nice point on here that you can already see, so you're going to have to approximate. So think about it, it's a positive 1.7. It's about there. It's not quite 2. So I'm going to label that. I'm going to say 1.7. They do not do that in the answer key, okay, in the math you see, but I want the kids, students, whatever, to label that point. All right, now decide, is it an open point or is it a closed point? Because it says or equal to, it has that line, it's saying, hey, I want you to include 1.7. So this time, we're going to do a big filled-in point. That tells me that I am including 1.7, and then it wants everything less than that. So just like we did on the other one, we're going to shade this in. Mine's nice and crooked because I'm trying to do that while holding the phone. So it's going to look like that. That is your answer. Okay, this you're showing it by plotting it on a number line. This is the same answer using an inequality symbol, so the same thing. Okay, one other thing. I noticed there's several problems in the book. For example, I'm looking at 5C number 8 and also 5B number 18, it asks questions. It says something like, in the first quadrant, X is blank and Y is blank. And I've had some people asking me, what do they want there? They're wanting to know what are the values. If you have any point up here in the first quadrant, your X is always a positive value. So they're wanting you to say X is positive and your Y is positive value as well. Okay? Plot one point, any point in this first quadrant, and it doesn't matter. The X value will always be positive, and the Y value will always be positive. And we're talking about, like when you have an ordered pair, I'll do that over here, like I'm just making one up. But if you had that point 5, 2, notice that's in this is your X value, this is your Y value. That would be in the first quadrant, and notice that both of them are positive. That's true with any point in that first quadrant. Okay, so in the second quadrant, notice I'm having to go this way to get in the second quadrant, which is your negative numbers. Okay, so your X would always be negative in the second quadrant, and then I'm going to have to go up, so my Y values would always be positive. So that would be what they would want if you get asked that question. So on 3, if you're in the third quadrant, notice to get to the third quadrant, I'm having to go left to get to my X's. This is your X-axis. If I go left, I'm going to negative values. So my X would be negative. And then if I would go down, my Y values would also be negative. Every point in the third quadrant, both the X and the Y value would be negative. Look at some of them that you've plotted that are in the third quadrant and you'll see what I'm talking about. Okay? Okay, last but not least, your fourth quadrant. These would be positive. Okay, to get down in here, your X's, you're going this way and then down. So your X's would be positive but your y's would be negative. So that would be x is always positive and y is always negative. So hopefully that's helping people just finish up a few of the problems. Okay, I want you guys to think hard and do a good job on these. And if anybody has any other questions, all you have to do, remember, just ask me. You can call me, Facebook me, text me, let me know, and I will get this on YouTube as fast as I can.